Hello everybody, this is the fourth video clip of chapter 2 for the cost calculus for business 2. Okay, so this one is just to wrap up some of the example that we still left over. Okay, so this one saying that a company extracts minerals of the ore. The number of pounds of mineral A and B, so you are talking about two minerals, okay, the A and the B, that can be extracted from each ton, okay, of ore 1 and ore 2, given in the following table. Of course, together with the cost per ton of the ores, okay. For example, the first mineral, okay, obtain 100 pounds in the ore number 1, and we got 200 pounds, okay, for the same mineral for ore 2. For the second mineral, the first ore contained 200 pounds, but the second ore contains only 50 pounds, and the cost per ton, okay, is $50 for the first ore, and the cost per ton for the second ore is $60. And if it's saying that the company must produce at least 3,000 pounds of the mineral A and 2,500 pounds of mineral B, then how many tons of each ore should be processed in order to, of course, minimize the cost? Is it? And what will be your minimum cost? Okay, so let's say that you use X ton of the first ore and the Y tons of the second ore. So the what will be the cost? Okay, so the cost, or your let's say seed of XY, it depends on this 50 and 60, right? So it is because this one it is 50 per ton, but you use X tons, so it's going to be 50x. The same token, it is 60 per ton, but you use Y tons of second ore, so this one is 60y. Okay. However, you need to produce, okay, at least 3,000 pounds of the first mineral A. Okay, so it means that this one, if you use X tons of the first ore, then you obtain 100x pounds of the first mineral. Okay, so this one for the mineral A. Okay, you use 100 pounds. I mean, you got 100 pounds multiplied by X tons of the first of the mineral A from the first ore, and you have another 200 Y. Okay, you see here. Okay, because each ton obtain 200 pounds of mineral A, but you use Y tons, so you have 200 Y must be greater than or equals to 3,000, because you need at least 3,000. For another mineral B, okay, you are going to have a 200 pounds, okay, multiplied by X tons, and the 50 pounds multiplied by a Y tons, okay, of your second ore, and it must be greater than or equals to 2,500. Okay, and of course, I mean, because your X and your Y, there are a number of tons that you are going to use, so your X and your Y must be non-negative. So let me just clarify here that the objective C, it is depends on the number of tons of the first ore and the second ore, and it obtained by 50x and 60y, and you need to find the minimum of this. And the constraint, okay, you have, of course, X and Y must be non-negative, and 100x. I mean, we simplify a bit, okay? Instead of 100x, so you have x and 2y, right? X and 2y must be greater than or equals to 30, and this one 20x and you can simplify by another 5, right? Okay, so you have a 4x and a y must be another 5, right? Greater than or equals to 50. Okay, so you are going to draw a region, a feasible region, okay, and then you are going to look for a minimum. Okay, so let us draw a diagram. Now this one indicate that you are going to consider only the first quadrant, right? Only in this area. And then if your y is 0, your x is 30. So let me see, 30 is somewhere here. If your x is 0, your y is 30 over 2, which is 15. So it will be somewhere right there. So here we are. Okay. And you are again to determine whether you are using the lower part or the upper region. Okay, so the 0, 0 is right here. You plug in, you have 0 greater than or equals to 30, which is a contradiction. So the region that you need is the one that not include the 0, 0 point. So it is the upper region. Okay, the second one, if your x is 0, your y is 50. So this is 2, 3, 4, 5. Okay, this is 50. And if your y is 0, your x is 50 over 4. Okay, and 50 over 4, it is what? 12.5, is it? Okay, so your x is 12.5. So somewhere here. Okay, all right, so again you are going to determine whether you use the upper part or the lower part of the region. So here the 0, 0 is right there. You plug in, the 0 is greater than or 50, contradiction, right? So it means that your region is not include that 0, 0 point. So you need to use this one, upper. So together, this one you need the upper region, this one you also need the upper region of your blue. So it means that the feasible region is a region in the first quadrant, and it is above these two lines, right? So it is determined by 3 corners, and it is the unbounded region here. Okay, just like that. There is your A. Let's say your A is 0 and 50. Here can be your B. There can be your C, which is 30 and 0. So to determine the B, you need to solve this system of equation. So you can simply do it by multiply this one by 2 to have 8x and 2y equals to 100. Let me just use an equal sign first because we find the intersection, right? And you do a subtraction. So by subtraction, you have 7x equals to 70. So it means that your x is 10. So as your x is 10, you can figure your y by 50 minus 4x, but your x is 10. So your y is also 10. So here your B is 10, 10 as an intersection point. Okay. You are going to find the minimum of the unbounded region. So let us make sure by rewrite your objective line in terms of x equals to negative 50 over 60x and c over 60. So this one is a straight line with a negative slope. So it will be the line that's going downward like this. okay, and your C over 60 is the y-intercept. So as you move your objective line upward, your y-intercept will be higher and higher and higher. So it means that your cost will be higher, right? But you need a minimum cost, so you need to move downward, okay? Which is okay. I mean, if you move downward, you will hit either this point or this point or that point, okay? So the minimum occurs, and it occurs at some of these corner points. So let us evaluate the cost function at A first. So it is at 0 and 50. So it is 60 and 50, right? Or it is 3,000. At your B, it is 10 and 10. So it is 50 and 10 and 60 and 10. Or it is 500 and 600, which is 1100. So correct. And the last one is at the C, which is 30 and 0. So it is 50 and 30, which is 15,000. So where's the minimum? Here, okay, is the minimum. So what does this mean? It means that the company should use the order number 1 for 10 tons, and or number 2 for, of course, another 10 tons, in order to obtain enough mineral A and B, okay, and have a minimum cost of how much? $1,100. Okay, $1,100. All right. So this is the last word problem example that we are going to give it to you. Okay. So we'll see you next time. Bye bye.